Hello everyone, myself Dr.S.Omprakasam, Assistant Professor, Department of Mechanical Engineering, Sri Ramakrishna Engineering College. Today we are going to discuss time temperature transformation curves and continuous cooling transformation curve. General introduction about time temperature transformation and continuous cooling transformation. This is a very basic understanding level of how microstructure form in steel during heat treatment process. Let us see. This is a time temperature transformation curve. We can see x-axis is time and y-axis in temperature, and A1 line 723 centigrade line to austenite is stable austenite is there, and austenite is transfer the microstructure perlite, bainite and martensite. It's a time temperature diagram too. We are going to see austenite is transferred to martensite with respect to temperature and time. First we can see stable austenite is transferred to coarse perlite and then fine perlite and upper bainite, lower bainite and come to the martensite starting point and martensite ending point. You may be asked, what is this C curves? This is the transformation starting point, this one is starting point, ending point. In between microstructure is varying. It is also called as CNOS. This exactly 550 degree centigrade to is happening. CNOS point is 550 degree centigrade to is happening. First we can start 723. 723 above is the stable austenite is there. 723 below coarse perlite will be started. Here is the transformation starting point. You can note it here. Transformation starting point. This transformation starting point to coarse perlite is available here. Coarse perlite is available. From this, with respect to time over the time period, it's transformed to fine perlite is transferred here, fine perlite. Around the temperature is 700 to 600 centigrade. Which come below exactly 550 centigrade means exact bainite will be started. 550 above is the upper bainite, 550 below is the lower bainite. Exact 550 centigrade to bainite is available. Again is come down, is around 300 centigrade to martensite is starting. It's come to around below 100 centigrade to martensite is entering. From this time temperature transformation to we are easily understand that how microstructure is varying from each and every temperature. Around 900 is already is a stable austenite is there. It's come to below 100 centigrade means martensite is there. Suddenly if you are going to heat your material, heat treatment process too, suddenly you are going to heat your material, immediately if you are doing any quenching process, austenite is transferred to martensite. Sudden cooling to is austenite is transferred to martensite. If you are maintaining in the furnace in room temperature, if you are maintaining means automatically its transformation is start, coarse perlite, fine perlite, upper bainite, lower bainite and finally is come to the martensite. This 5 microstructure will be created from this temperature variation. This is the most important from time temperature transformation to we are understanding. Where we are applying this time temperature transformation diagram? As an engineer, we are going to apply the dynamic load wherever is a possible dynamic load. So low carbon steel we are applying in the gear wheels or turbine blades or some other applications. Dynamic load wherever is applying that place to we are using steels, that material to time temperature transformation is most important. This is the basic understanding based diagram. Another important thing is time temperature transformation diagram to in between what is going to happen, upper bainite and lower bainite, how it's creating based on the temperature and based on the time period is slowly cooling. Room temperature to is slowly cooling 720 degree to around 10 minutes or 15 minutes or 30 minutes is the time period is step by step is reducing. From that microstructure is transferred from upper bainite and lower bainite. In between this area, entire area, CNOS, this is called CNOS area, this entire area is a bainite region. Bainite region to perlite is around 40% and also bainite is a 60%. In case more than that, if you come to here, carbon content is high and sudden cooling means it's transferred to cementite. carbon content is a low carbon steel means 0.02, 0.02 is a low carbon steel is available. That low carbon steel too, we can see the entire time temperature transformation step by step, line by line. In continuation of this continuous cooling transformation diagram, this time temperature transformation diagram with respect to time and temperature, if we are going to enter the continuous cooling transformation diagram, most important thing is time and as well as temperature as usual. Triple T2 we understand from here also. Only thing, cooling media we are using, what type of cooling we are using, there we are used in atmosphere cooling only, atmosphere cooling in holding in the furnace. Come to the time temperature transformation diagram. First we are used in sudden cooling process. Sudden cooling process means this portion is austenite and this portion is martensite. Here suddenly if your metal get cool, austenite is transferred to martensite. So once we are done heat treatment process, after that immediately we are going to quench in water, automatically is transferred to the martensite structure. Another thing, if you come to this one, is you can understand this is 1 and this 2, this is 3. 2 we are maintaining in furnace and atmosphere cooling process we are maintaining. It means at the time transformation starting point Ts and transformation ending point T, all the point its meet and all the structure is transferring, Fearlite, upper binite, lower binite and martensite, all the things is happening in furnace cooling. If we are using furnace cooling means this all the things is happening. Here water sudden quenching to third one to suddenly is transferred, austenite is transferred to the martensite. If we are using one is furnace cooling is atmosphere condition to we are cool the entire material. Is come to the second one. Second one is a oil quenching process. We are going to oil quenching means it slightly touch on the C nose, binite will be appear and automatically is transferred to the martensite. First one austenite is there in oil quenching process and comes to the C nose curve point is a binite, upper binite and lower binite in between that will be touch and after that is come to the martensite. This is the most important transformation of continuous cooling transformation. 3 different medias we discussed. First one is the third curve is austenite is transferred to the martensite with respect to water. The second one is a oil quenching process, austenite is transfer, phase transformation is appear in the binite and after that is entered in the martensite. Come to the first one, we are maintaining in the furnace, the atmosphere cooling process we are holding, from that what is happening, austenite is entered to the Fearlite, upper binite and lower binite is come to the martensite. Entire transformation is transferring. Before one, time temperature transformation to each and every material we are holding in around 750 centigrade means austenite with respect to time period, over the time period is automatically microstructure is transfer. Here continuous cooling transformation to we are adding the cooling media, based on the cooling media whether it's a water or oil or pressurized air or atmosphere condition, whatever it is, based on that each and every structure is varying. Your requirement is martensite is required, even though you are a low carbon steel is martensite is required means automatically we can heat treatment process will be completed means suddenly you can use quenching process. But your material is required is a binite condition, binite structure means you can go with oil quenching process. Whenever your quenching is going to enter, automatically we want to go the tempering process also. As tempering and mark tempering is entering, depends on your material and depends on your application and customer requirement to as tempering or mark tempering, you should maintain that. That is most important. Another thing, your requirement is all the structure is required, naturally how its material is there and similar natural properties is required means atmosphere cooling too you can maintain. This is the most important. Compared with the time temperature transformation, CCD entirely is different. time temperature transformation with respect to time and over the time period, temperature with over the time period, how it changes only we are checking. Come to the continuous cooling transformation diagram, same time and temperature, another thing we are extra, we can add the cooling media. Based on the cooling media, how it's transferring, we are going to understand that. So come to the next slide for better understanding purpose. Your different cooling treatment process, how it's your material is transferring. This is the utertide state. Normally we know that the entire 723 is a utertide things. Utertide reaction with respect to iron carbon diagram. One solid is transferred to the two solids. Solid 1 is ferrite plus perlite matrix. Solid 2 is perlite plus martensite matrix. This is the common thing. Everyone know that with respect to utertide reaction, one solid is transferred to the another two solids. One solid is first one is the ferrite plus perlite matrix formation, second one is perlite plus martensite formation with respect to carbon content. This is most important. Based on the carbon content, this will be entirely varying. Okay. This is my martensite point, martensite plus perlite and fine and coarse. You can see here water quenching process, austenite is transferred to the martensite. Come to the oil quenching, martensite plus perlite is come to the almost upper bainite and automatically is enter the perlite portion. And come to the normalizing process, normal atmosphere condition you are doing that time fine perlite we will get from all the transformation, is all the transformation point starting and ending, all the things will be crossing almost CNOS point 550 degrees centigrade, everything will be crossing. After that we get the fine perlite. If we come to the full annealing process, entire heat treatment process is going to appear. That time all the coarse perlite we will get. Based on that all the normal annealing, full annealing process, normalizing process, process annealing process, all the things will appear on this area. We will get the entire things. From time temperature transformation and continuous cooling transformation to, we are easily understand where we are going to apply based on the customer requirement. We can choose the microstructure as well as the temperature region also. Which temperature is, if we take example 550 centigrade means automatically your material get bainite condition. If you come to the 350 centigrade means martensite starting point. If you come to the 250 centigrade means martensite only. Exact martensite is that. Depends on cooling media and depends on atmosphere condition, we will get entire microstructure transformation. This is we are understanding from the time temperature transformation and continuous cooling transformation. Conclude the today's session. We are understand the triple T diagram and as well as continuous cooling transformation diagram. From this diagram we will understand the how microstructure transform in steel during the heat treatment process. Thank you.